I always like to work on several things. I'm not in only one field. And I've been varying fields. But just now I am in two fields, essentially. One is physics of plasmas, and the other one is system science. If you get a gas and you heat it at very high temperatures, let's say above 10,000 degrees Celsius, the electrons and ions separate, and you have a plasma. That's what is in the atmosphere of the sun and in many other hot places. Now, you need to make a bottle to put this plasma in, and you do it with magnetic fields. You make a magnetic bottle to keep it in and keep heating it. If you choose the right atoms, then you can have fusion reactions. And that is the basis for of a fusion reactor. And the problem here, the basic problems that we are facing, is to keeping the plasma as long as possible within the bottle in such a way that the reactions can take place and the thing self-maintains. The other area is system science. In system science, we are worrying about infrastructures, for instance, all systems built by men, which involve economical problems, involves physics and engineering problems, and which are characterized for having very large disruptions, and to try to understand the origin of these disruptions, to try to understand the mechanisms, how they can be more effective, and sometimes intuitions that one has to improve a system make the things worse. Then that's what we try to analyze. And you can ask why I'm working in plasma physics and system science, what they have in common. Well, it's very simple what they have in common. A sand pile. You get some sand and you start dropping the sand on the floor and you'll make a pile. And if you keep building the pile, you'll see there is one phenomenon, typical phenomenon, is the angle that the pile makes with the floor is more or less always the same, oscillates on around one value. It's a critical angle. It's a critical point for the sand pile. And if you watch carefully the grains of sand falling, you'll see that coming out of the pile are not going to be grain by grain. They are coming out in avalanches. The pile stays okay for a while and then suddenly it drops large avalanches. Then these three things, a continuing pushing of the system, a critical point, and the avalanche way of relaxing the system are three things in common between these two fields. And it's what have linked our research efforts in there. Our direct application is trying to understand how the particles leaked out and how we can try to keep it inside of the bottle as long as possible. What are the mechanisms of going out, the physics involved on that. And interpreting some experiments here in Madrid also, there is one of these magnetic bottles which we have been working at the CMAT, and we work also with the experimentalists there, trying to understand what's happening, what they're measuring, interpretations of what's going on. That's one of the focus. On system science, we are interested, especially we are working recently more in the question of the electric grid, and trying to understand these large disruptions, the blackouts, large blackouts, what are the probabilities of these blackouts, and how to minimize this probability of large blackout happening, which is not an easy problem. Our central project here has been to try to understand the topological structures of the flows inside of a plasma. I'm working here with Luis Garcia from the Department of Physics and with Irene Llerena from University of Barcelona. She is topologist, Luis is physicist. And we look at the flows inside of the plasma, and they have very peculiar, due to the magnetic field, structures there. You have the formation of vortices, which have a toroidal kind of topological structure. And we are kind of developing ways of analyzing these structures and try to see what are the implications for the particle transport out of the bottle. And it's been very interesting. I mean, one of the papers we have published this year is being selected by the European Physical Society as one of the highlights of the year. And we will keep going on that. I would like also to get involved with somebody, or some people here on the question of the system science. I mean, that's something who has a lot of possibilities. But at this point, I don't have any collaborations within the university.